Actually, we looked at the cosine 3t, 4 times cosine 3t, but you know. So let's remember, let's not go through those transformation ideas. You remember what happened to amplitude lines? What are the top amplitude lines? By looking at this one. Vertical stretch changes your amplitude line from y equals 1, y equals -1 to something else, right? So how is the vertical stretch involved here? Multiply by 4 or 1/4? 4, right? So that becomes 4 and y equals -4. Those are the two horizontal lines. This motion is going to go all the way up to 4, all the way down to -4, back and forth, right? That's the motion, one-dimensional motion. If you sketch it, goes up and down like that. Make sense? How about this period? Period was originally 2 pi. Remember, from 0 to after 6.2 seconds, which is approximate value of 2 pi, right? After about 2.6. Later, it comes back to equilibrium position after you're hitting the highest position and lowest position. That's the sine motion in here, right? But what is this 3 times t doing? Is this shrinking or is this stretching? Right. The horizontal factor, that's in front of t, but the vertical stretch factor is not in front of y, right? That's why it worked a different way. So the factor is 1/3. Remember, that's the horizontal, in quote, stretch factor. It's actually shrinking. So 2 pi is shrunk by its 1/3 of its size, right? So 2 pi times 1/3. Where's 1/3 coming from? Reciprocal of the number you see in front of t. That's the algebraic description of this one. So within this shorter period of time, that is going to repeat the one cycle. The period got shorter. This is kind of summary of what we did last time. Does that make sense? Yeah. So if you look at this, amplitude line in perception of sound wave, this is how loud the sound is, and the period correspond to the pitch, right? And how do you calculate frequency in here? Remember, how is this frequency and period is related? Right, it's reciprocal of period. If that's the period, and frequency is just a flip of this one. 3 divided by 2 pi. So we looked at some examples, period 3 cycles in 1 second and things like that. We looked at that example to observe this period and frequency. So whenever you look at period and frequency, you don't want to think about that example and spending time on that one. This is very simple algebraic relationship, so I want you to just simply memorize it. That's one of the things that mathematics do, is that you cannot just rethink everything. It is just, built on top of each other. It's impossible to feel everything. You have to rely on this mechanism. If you rely too much on the mechanism, it becomes just rote memorization and bad effects. So we have to balance out. So this is one of the things that you don't want to repeat again. Period and frequency is just flip. Okay? That's kind of the summary. So here's the general description of this curve, and they are summarizing like this. Hope this formulation makes sense now. They're introducing 2 types of curve. One is y equals a times kx, right? Another one is y equals a times a cosine kx. Which are of this type? You see that a here is 4, k here is 3. Instead of t, they're using x, so we're looking at the curve like this: y equals a times sine of k times t. Is that right? And the other curve is y equals a times cosine of k times t. Okay? This a can be positive and negative. All right? If this a involves a negative number, then what comes to your mind? Reflect, right? If the graph is reflected. If it is a sine, it begins to go down, not going up. If this is cosine and negative is involved, It doesn't start at the top amplitude line, it starts at the bottom top amplitude line. Those are the things. What if this k involves a negative number? What you can do, you can clear that negative inside the sine and cosine. This is called even and odd property. Remember? If you have negative number in here, what happened to sine? Does it go outside or disappears? Go outside. That's the odd property. And if it's inside the cosine, if you have cosine of negative 2t, should we pull this negative outside or just ignore it? Change to positive. That's even property. That changed to positive. All right? Not all functions have this nice property, but sine and cosine has that nice property. So you can clear the negative sign inside the sine and cosine and put it outside and use the same reflection idea. Make sense? Yeah. So that's why they're saying amplitude of this one is going to be absolute value of A. Why are they putting absolute value? It could be a negative number. So we want a positive magnitude, right? So for example, if I'm looking at y equals negative 4 cosine 3t, what is the amplitude line? Still 4 and negative 4, right? It's just that this negative will change the initial position or initial direction, things like that. Make sense? Yeah. But amplitude is, what is this amplitude of this one? 4. That's what we say. Amplitude is 4. The positive quantity of it. That's what they mean by absolute value of A. Let's see the period they're talking about. They're saying period of this curve. What is a period? Let's at least think about that one. What was the definition of a period? Period is time, right? Period is a time. Time for what? Time that is required for one cycle motion or one cycle motion. How long does it take to build one cycle? So they're saying that is 2 pi divided by k. So let's see. Where do you think this 2 pi, remember, 2 pi is the original period of the sine t and cosine t, right? Where did this k in the denominator come from? Anybody remember? Right. This one is k, 3, right? But why is this going to denominator? Horizontal stretch factor, which is reciprocal, right? Okay, that's why it's going there. So it's a 2 pi by 3. That's the formula they're introducing. Make sense? That's the period. So I want you to now remember. You understood it. Now I want you to remember that amplitude is that, and period is quickly computed like this. If they trick you with a negative 5 in t inside in here, what is it? 2 pi divided by positive 5. You got to take care of that negative inside there. All right, that's a quick way of reading an amplitude and period. It's important information to determine the nature of the curve. All right, let's see some example to get used to this. So they actually put it, they're going to say the k is a positive. And you can change the formula to this shape where k being positive. So, for example, in this problem here, we're not going to think about stretch factor or transformation, none of those. We just look at it here, think about quick way of thinking about this problem. Let's look at, I'd like 22. Let's look at 22. Y equals, I'm going to make this one exercise. Y equals 5 times cosine of 1/4 times t. That's a curve. Find the amplitude and period of this function and sketch its graph. 3 parts, all right? No transformation, no nothing, right? So I want you to look at this curve, recognize that this curve is in the form where we just described, and try to read off these two important information, amplitude and period of this function quickly, and hope you be able to actually sketch it with this two information. All right? And then we're going to think about reference points together. In this time, this stretch factor changes this curve shape really very difficult to sketch. So you can just sketch the usual thing and just put the reference points correctly. But that's just roughly sketching. That's your exercise. All right. This is cosine graph with no reflection, right? What is involved is a vertical stretch and a horizontal stretch. So it doesn't really look like this, but it's kind of shrunk to a stretched version of this. Now, if it is like that, it's kind of challenging to sketch it nicely and neatly. So I'm just keeping this usual cosine graph and just write down the correct number and hope you understand from this time on that it's actually very stretched version. Is that right? How about amplitude? You got everybody that got 5, right? How about period? You got 8 pi. 2 pi divided by k. K here is, what's the number, k? Yeah, 104. So that goes to the denominator. It flips and becomes 8 pi, right? Whereas the meaning of the 8 pi, period, time it takes to complete one cycle, here's a cosine motion. So it starts 0 and end up at 8 pi, and that repeats one motion. Starts at the top, hits the bottom, and coming back up. Right? That's the graph. One additional thing I'm going to do, this is like putting the reference point and putting this amplitude line correctly. So endpoint is the period. Starting from 0, endpoint is a period, 8 pi, right? Good? Now this is one in the middle, therefore 4 pi, this, and so on, right? But let's use that number that you already know. This was supposed to be pi over 2 before it's stretched out or shrunk. But what is the factor we are multiplying? Right. It is not 1/4, but it's a 4, the reciprocal of that one. So that's the factor, right? You have to multiply 4 there. Think about what is multiplied to there. That gives you an idea. How about this one? Originally pi, but you have to multiply 4. How about this one? Originally with a 3 pi over 2, right? But it's got to be multiplied by 4. This 4 is the factor, the reciprocal. All right? Does everybody understand where the 4 came from? 4 is a reciprocal of k. These are reciprocal of k. Why reciprocal? That's how the horizontal stretch factor works. Make sense? So if you sketch it like this, and you put 5 and -5, you think about this is, however its actual version is the scaled correctly version. But we're going to stick to this handsome one like this and put the numbers correctly. Any question? Let's think about problem like this. 24. What do you want to do about that problem? Number 24. Y equals 4 times the sine of -2x. Right. You take care of negative first. Make that coefficient of x positive first. Then it's a standard form. All right. Do you see anything else in this group that we definitely have to do things like this guy in here, like this guy, 26. All right. So I'd like to make this one exercise, 26. Make sure this time we're going to do all the reference points as well. All right. So find the amplitude, period of the function, sketches graph with reference points. So that's the exercise 26. There's a question, Cosine? Exercise number 26 first. Blah, 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 which is there with reference points, right? All right, how was it? Amplitude line 3 and -3, right? And the period is a 2 pi. That's always there. And what is k here is pi. What's in front of the t is pi. So that goes to denominator right there. And pi cancels gives you 2 seconds. So period of 2 seconds. After 2 seconds, how many cycles repeated? Because the period is 2. After 2 seconds, how many cycles, what is the number of cycles you see in that over the time period 2 seconds? 1 cycle, right? That's the meaning of the period. So what is the frequency? That means that given 1 second, how many what is the number of cycles? 1/2. It doesn't even complete the whole thing. It's a reciprocal of that, right? So it only repeated half of the cycle. That's the meaning of the frequency. Right? Given 1 second, what is the number of cycles it repeats? How about these reference points? The original reference point is in green, pi over 2, pi, 3 pi over 2, and 2 pi there, right? And they're multiplied by the factor. What is that factor, or stretch factor? 1 over k, which is 1 over pi here, right? So these are multiplied to that reference point to get that. Does that make sense? All right. So that's that. So I shrunk a little bit. That, this is 3 and this is supposed to be 2. So it's actually a lot shorter period. You can see this is 3 units. So it's supposed to be over here. So it's quite shrunk toward to the y-axis. Any question about the shape of this graph? Is that okay? All right. So our next question was this number 23, which is like this. Let's think about this problem a little bit. Let's see what it does. All right, let me restate it. It's so tiny. Y equals negative 1/3 cosine of 1/3 t. That's the thing. Amplitude. Let's do this one together. Amplitude is a positive 1/3. Is that right? When you do that, you either switch the sign or not. So when you switch the sign, it seems like it's a wise thing to do to write down reflection involved, right? Because you just switch the sign of this coefficient. So record that. I'm going to reflect it. And what is the next thing? Period, right? Period is 2 pi divided by what's in front of here, right? It's 1/3. So what do you get? 6 pi, right? Pi doesn't cancel. So it's very slow motion. 6 pi. All right. What if this had a negative inside? So here's a little remark. Well, did that kind of answer if you have amplitude and period? And what is the stretch factor? Seems like that's one thing that we use to write down this reference point. So let's record that as well. Stretch factor. Remember what the stretch factor is? What is in front of t? Is that the stretch factor? No, it's reciprocal is a stretch factor, right? So it's reciprocal 1/3, so it's 3. 3 is the stretch factor. The graph is stretched away from y-axis. Factor is 3. So 3 is going to be multiplied to those reference points. Is that right? So let's write down those reference points. What is the first reference point? Pi over 2, right? But you multiply by 3. So it's 3 pi over 2. That's the first reference point. Second one was pi, right? Multiply by 3. It's a 3 pi. Third reference point, 3 pi over 2. Multiply by 3, right? So it's 9 pi over 2. The last one was 2 pi multiplied by 3, so you get 6 pi. Those are the reference points. It hits a peak, coming back down to equilibrium position, and hitting the lowest amplitude line, and so on. Does that make sense? These are the information that probably you want to write down immediately before you sketch or something. Okay? Any question about 23? Here's a little remark that I was about to put down. Y equals negative 1/3 and cosine negative 1/3 t. How about this one? Reflection involved? What are you going to do about this negative? Then you go back to case that is similar to this one, where inside is a positive coefficient. So, do we pull this one out, or cosine, right? Cosine even or odd? Even function. So what happened to negative? Survives outside or disappears? Disappears, so it's the same as before. Positive. So same thing. Reflection involved or not? It is involved. It is negative out there, right? It's involved. How about this guy? Y equals negative 1/3 sine of negative 1/3 t. What are you going to do about this negative inside? You change it to, we ignore or pull this one out? Sine is odd function, so that survives. So that makes outside negative, negative, positive 1/3 sine 1/3 positive t. Is that right? So that curve here is identical to this curve, although they look different, right? They're identical to this one. Is this one involved reflection or not? No. So this curve actually involves no reflection. So the motion of a sine starts in equilibrium position, right? If there is a reflection, it goes down. If there's no reflection, it goes up first. If it's cosine, there's no reflection, it starts at the top position. If there is a reflection, it starts in the bottom position. Does that make sense? Yeah. So that's why I did this remark. If there's a negative inside, take care of it first. And after that, think about whether there is a reflection or not. Right? Don't just look at here, there's negative 1/3, so there's going to be no reflection. Not like that. Any question? All right. Sorry, I wasn't recording, but this whole thing is applying a shifted version to this original graph. All right, so up to here is all the same. So we have to write down reference points. So here's a reference points. What was the original one? 0. This time we should start from the 0. 0 never gets your attention, right? Because it's always there, it never changes. This time it's shifted. So 0 is coming to play. 0 times stretch factor. Let me be just consistent, although it's a silly thing I'm doing. What is a stretch factor? 1/2 multiplied. Then what do we do? Shift. Horizontal shift by how many units? Plus pi over 4. That's what's shifting. So that's your first beginning point. That's the initial of this thing. All right? What is next one? Standard reference point. Pi over 2. Is that right? Multiply by 1 over 2. That's a stretch factor. Plus or minus? Plus pi over 4. All right, horizontal stretch factor and horizontal shift term. Okay, so I'm running out of space here. So let's write that. Well, let's work this one out vertically. So I'm going to do it like this. That's the first stretch factor. So let's do this one. So what is this? Pi over 4? We start at the pi over 4. Next time we arrive at here, this is pi over 4 plus pi over 4. So what is it? Pi over 4 times 2, so it's a pi over 2. Is that right? Okay. What is the third standard reference point? And that pi, right? Stretch factor, 1/2, correct? And shift term, pi over 4. So that's pi over 2 plus pi over 4. Isn't that right? Common denominator, 2 pi divided by 4 plus pi over 4. Putting into a common denominator, right? 1/2 is equal to 2/4. That's what happened here. 1/2 is 2/4. So that's 3 pi over 4. Okay. So what is the last one? 2 pi, no, the 3 pi over 4. So 3 pi over 2, sorry, misspoke, multiplied by the horizontal stretch factor 1/2 plus pi over 4. Isn't that right? So what is it? 3 pi over 4 plus pi over 4. Ain't this right? So together, 4 pi over 4, 4 cancels, become pi. Good? So that's a 0, pi over 2 pi, and 3 pi over 2. So what is the last one? 2 pi times stretch factor plus the shift term So pi cancels. 2 cancels here, and pi plus pi over 4. Put into common denominator, what is it? 4 pi over 4 plus pi over 4. Does that make sense? You have to change that 1 to 4 divided by 4. Have a common denominator, and numerator is 5 pi over 4. All right? So you started here. Is this a sine curve or cosine curve? It's a sine curve right there. The sine curve. So you start at that position. So going up or down? No reflections involved. We wrote it down. So start at the equilibrium position, but the t-value start at the pi over 4, going up, hitting the highest points at pi over 2, coming back down equilibrium position at this many seconds later, and lowest position and that many seconds later, and so on. All right, so we're going to sketch it. You don't have to be in the perfect scale, but at least I want you to be shifted. Shift version have to be correctly sketched. So here's a graph. T, and here's y. And what's the amplitude line? 3 and 8. So always it's just about here. Scale is not going to be correct. But as long as you write down the coordinates, educated people will understand how this one actually is supposed to look like. So where is the start position? Was always 0 so far, now it changed. Pi over 4, this is where it starts. Right? It's the important part. Pi over 4. So you're going to put it here. Pi over 4, that's your box. Pi over 4. At least this should be correct. If this is pi over 4, what is a period? Period is a pi, right? So it's 2, 1, 2, 3, 4. It's just about here. I think that's roughly the interval is a pi. But what is the last coordinate? Anybody remember the last coordinate here? The last one is a 5 pi over 4. That's where it ends. 5 pi over 4. Does that make sense? The in-between, the interval between the beginning of this cycle and end of the cycle is supposed to be what number? That one here? That's supposed to be the period. Did we calculate the period? Period is a pi. So that's correct. That's the length is supposed to be pi. Starts at pi over 4, ends at 5 pi over 4.
So it's longer than the actual? I don't understand. So 1 period is pi, but we calculated 5 pi over 4.
Right, that's just end coordinate. So here is a confusion. The end coordinate of this box is not the period. It was a period because your initial of the box was 0 before. So slightly new formula. Beginning of the box and end of the box, if you subtract these two, that becomes period. So here's a 5 pi over 4. That's the end coordinate. What is the beginning coordinate? Pi over 4. So that's a 4 pi over 4. So that's pi. And you can check and the consistency in here. Before, this was a 0, right? So the end coordinate minus initial coordinate 0, that end coordinate itself was a period. So don't think this is a period. This is actually the common mistake in the test. I remember now. This is not the period, right? So that the difference is the period. Okay. What is the next part? We're going to sketch non-reflected sine graph in here and just put these numbers, and that's it. So here's you just half it, go up, non-reflected sine graph, right? Coming back down, and here, and go stretch a little bit. This is amplitude is the same as before, is shifted. How about period? Shifted or not, does the period change? Doesn't change. That this beginning and end point of the cycle, after you shifted, that interval, the length of interval doesn't change. So period remains the same. Period corresponds to frequency. Frequency is your pitch, right? So if the sound waves is shifted around horizontally, even vertically, the pitch, the frequency doesn't change, right? is just a little delayed motion or not. All right? Shifting does not change this very nature of a sound we perceive. Amplitude, how loud the sound is, and what the frequency of the sound we're listening. Make sense? All right, it's a bit involved, but up to here is exactly the same. You got exhausted a little bit because of this algebra, little arithmetic that is involved. But it's quite consistent. You multiply the factor and add the horizontal term. Is that right? So let's practice. Time for practice. So I'm going to show you. So let's do something that's similar. I'm going to do 31st. Restate it. So here's your exercise. Y equals 2 sine t minus pi over 3. So you're going to sketch the graph of this function with reference points and amplitude line. But find the amplitude and period, identify stretch factors, things like that. So let me list them down. What are those things that is involved in here? Amplitude. When you do that, you write down amplitude lines. The amplitude lines. And think about reflection or not, right? Colon. Next thing is a period. You calculate the period, and then you think about what kind of thing? Horizontal stretch factor. Horizontal factor. And lastly, you think about shift. And with that, compute the reference points. That's kind of order of doing things. So reading off, the amplitude and period is, I think you got used to it. This is what the book is requiring. Compute the amplitude and the period and amount of shift and sketch the graph. And I'm saying when you do that, write this additional information down. Amplitude line, where the reflection is involved, or what is the horizontal stretch factor, and what are the reference points after you shifted. Then sketching get a lot easier. All right? Although it's a lot of things, it is kind of rooted to these three things that you probably remember. So try to kind of expand out of that. So that's your exercise. All right, this time the horizontal stretch factor is 1, right? There's nothing multiplied in front of t, so it's just 1. It's just a horizontal shift that is involved and amplitude line. So period is still 2 pi, and stretch factor, horizontal stretch factor is 1, and horizontal shift amount is positive pi over 3, right? If this were, and then I calculated these reference points, I'm not going to go over again. So I'm listing them down here. Okay. Again, the period is distance from the initial of the box and the terminal, the right end of the box. So if you actually subtract it, you verify this is actually 2 pi. And if this were positive pi over 3, and everything is going to be negative pi over 3 here, right? That's how it works. Is that okay? All right. Any question about this one so far? The precision make sense? All right. Gets worse. All right. This problem is there to trick you. Nothing different. It's just to trick you. All right? So I'm going to help you to not being tricked about this one. That's all. That's all. Cosine of 2t plus 2 pi over 3. All right? So what's different from earlier one? So 3 over 4 times cosine of 2t plus 2 pi over 3. That's what it is. What's different from earlier one, and it's not even written here, but the earlier one, there I used two parentheses if you remember. There's a parenthesis for cosine, parenthesis around the t minus pi over 4. Okay, the original one. But there's only one parenthesis, right? And here's a positive 2 pi over 3. So does that mean it's horizontal shift to the right or left? It's left by how much amount? 2 pi over 3 is incorrect. That's why this is tricky. You have to write it as a 2 times a parenthesis t of something. Then whatever inside the parenthesis correctly tells you amount of shift. So here's the part that you have to do. You have to rewrite it in the following form. 2 of t of this plus thing never changes, so you can keep it like this. Whatever the correct shift amount there. If it is like this, parentheses and parentheses, and whatever that be as a positive number, that's the correct amount to shift to the left. Alright? So we're going to do this algebraic transition first, and then think about shift amount. Everything is the same. If this is like this, what we want is that 2t plus 2 pi over 3 being equal to what? The whole inside, right? 2 parentheses t plus b. We want these two things identically equal, right? Algebraically. Then these two things are equal to each other. You believe that? You just have to figure out what this b is. As you expand right-hand side, it's 2t plus 2b. Do you see that 2t cancels? It's not the choice of a b is not depending on the t. That's nice, good sign. B is supposed to be an absolute number without involving t. So what is left in the left-hand side is a 2 pi divided by 3 is equal to 2b. Is that right? So I'm going to divide both sides by 2, and what is b? If you divide by 2, it's a pi over 3. Is that right? Pi over 3. So b is actually pi over 3. Well, that was easy because you can just factor out 2 at the beginning, right? But if you don't see this common factor, and then this method will explain that better. All right? So here's a little remark. What if it is a 2t plus pi over 3? Just like I said, there is no common factor to factor out. All right? Then what you're going to do is you can factor out 2 like this and t and think about what to do with the rest of it. Pi over 3 was originally there. There is an even 2, but I force that to be factored out. But there wasn't a 2. So the way it works is that if there wasn't a factor of 2, you got to kill that by putting that factor in the denominator. If this factorization doesn't make sense, then you have to do this, which makes perfect sense to everybody, right? So you look at here, 2t plus pi over 3. Why is it going to be 2t plus b that you're looking for? And if you solve this one, then you can calculate b must be pi over 6 in this case. But in that original case, it's pi over 3. So I introduced 2 method of figuring out the b. Do you understand there was a 2 method? Okay, this is a fast method. Many people like this one. But if that's not helping you to understand what's going on, then you have to do this one. All right, there was no parentheses in it. If I put the parentheses, what's going to be in that b? You set that inside equal to each other. You can figure out b. Yes, Kristen. That's right. That's a quick method, right? Is that right? But we're back to here. Back to here. So that's a b. So let me rewrite it. The graph y equals 3 over 4 cosine of 2t plus 2 pi over 3 is equal to 3 over 4 cosine 2 parenthesis t of b, right? We figure out what that b is. B is pi over 3, right? If you just look at it here, all I did was factor out 2. But what if it's not that simple, and I also explained a little bit in generality. All right. So now because t is in the parentheses, from here we can read off the shift amount correctly. What is the shift amount by looking at here? Horizontal shift amount. Right, negative pi over 3. Right? If this were t minus pi over 3 was a positive pi over 3 horizontally. If it's t plus pi over 3, it's a negative amount of pi over 3. Again, these transformations explained in chapter 3, if that you don't recall these things. Okay? So once you have this horizontal shift figured out correctly, rest of the part is exactly the same. All right? So I'm going to make it exercise from here. Now you have horizontal shift amount, and do the rest of the part. It's about sketching the graph, identifying all that stuff. Remember? Amplitude lines, reflection, no reflection, period. What else? Horizontal stretch factor, reference point shifted is identified here, things like that. So go through all that. So if it's too long to remember, think about 3 things. Amplitude first, period, amplitude loudness of sound, period correspond to pitch of the sound, and this time shift. First you remember 3 things, and for each of the item think about additional thing to think about. That's one way to memorize this long list of things. All right? All right. Period was pi again. Stretch factor is 1/2. So I calculated those coordinates and carefully try to sketch it relative to across the negative axis and positive axis. Try to be a little bit accurate. Doesn't have to be accurate with the vertical axis, but across the horizontal axis it has to be a little bit accurate, right? So I looked at the initial point of negative pi over 3. So right hand side, right end point at 2 pi over 3. So I measured it roughly to make it right. So that's those reference points. Is that okay? Right. Write those information down when you calculate this thing. Then you can keep referring back to you. Do that a lot effectively and not making too many mistakes. All right. I'm going to do just one more thing. Right, and then I'll let you guys go. Right, I want you to take a look at these graphs. It's going to be quick. So let's look at 47 in here, the curve 47. I want you to first decide what kind of curve this one is. Do you think this is a cosine curve? Or is that a cosine curve? Do you think its reflection is involved in there or not? If it is non-reflection, it's kind of starting up, top part is started at the bottom of the amplitude, right? So it is cosine curve, and reflection is involved. Right? I want you to think about amplitude. Amplitude is not the amount of oscillation, this top coordinate and bottom coordinate, if they are perfectly symmetric like that. If the vertical is shifted, and it gets a bit trickier, but they don't have this thing, and we're not going to enter that. So what is the amplitude here? Right, 1/2, that's the amplitude, right? That's the either plus A or minus A, but because its reflection is involved, what do you think from there value A is? Is that positive 1/2 or negative 1/2? Negative 1/2, so that shows that a reflection is involved. So you're going to use a cosine curve, and the coefficient in front of cosine is negative 1/2. That's something we already know, right? What do you think the period of this one is? Period is calculating the right-hand coordinate minus left-hand coordinate, right? So what is the right-hand coordinate here? 2 pi over 3. And what is the left-hand coordinate? Right, this minus, and you have to write down the coordinate itself, negative pi over 3, like that. So what is the period? 2 pi over 3 plus pi over 3. So altogether it's just a pi, right? So we know the pi. What we want to know is k, so that we can write down the equation of this curve. So here's the thing. The period is a 2 pi, and I want to know k. How is the period and k is involved? It's 2 pi divided by k, isn't that right? The period is supposed to be 2 pi divided by k, where k is the coefficient. So if you solve this one for k, k turns out to be 2. So you know what's in front of t is 2, right? All you have to figure out is a shift amount. This is the initial point, right? Shifted by negative shift amount is negative pi over 3, is that right? Shifting is negative pi over 3. When it goes to graph equation, you have to change the sign. So here's how it goes. The final answer. Y is negative 1/2. What curve? Cosine curve, right? Cosine of what is the coefficient? 2. And then you have to put the parentheses carefully. Remember the parenthesis business. Is this positive pi over 3 or negative pi over 3? Positive. Go opposite. It's horizontal. Pi over 3. That's the curve. If you sketch that curve, it looks exactly like that. All right. Thank you.